3.2.2 Residential Receptacle and Lighting Branch Circuits. Branch circuits on electrical working drawings should show that the installation will meet the requirements of Section 21052. NEC Section 21052A provides the minimum requirements for the location of receptacles in dwelling units. It specifies that in each kitchen, family room, and dining room, receptacle outlets shall be installed so that no point along the floor line in any wall space is more than 6 feet measured horizontally from the outlet in that space. This means that outlets will be no more than 12 feet apart. When spaced in this manner, a 6-foot fixture cord will reach a receptacle at any point along the wall line. Okay. We call it the 12-foot rule. The code does not say 12 feet. The code says no distance greater than 6 feet from an outlet measured along the base board. Receptacle outlets installed on floors must not be connected as part of the required or counted as part of the required number of receptacle outlets unless they're within 18 inches of a wall. Remember that the NEC is a minimum standard. Therefore, as more electrical devices are used, it's wise to space receptacles closer together. So NEC Section 21052A2 defines a wall space as a wall that is unbroken along the floor line by doorways, fireplaces, or similar openings, and fixed cabinets that don't have countertops or similar work surfaces. Each wall space that is 2 feet or more in width must be treated individually and separately from other wall spaces within the room. So if a wall space is 2 feet or greater, it needs to have a receptacle. Figure 26 shows the receptacle outlets for a sample residence. In laying out these receptacle outlets, the unbroken floor line of the wall is measured and the receptacle outlets are then spaced equally distant apart. So from the door within 6 feet, you'll have a receptacle and every 12 feet around the room. Here's one, it's a GFCI, and then you measure from the door 12 feet, here's another one, go 12 feet, here's another one, 12 feet. I would say there'd have to be another one over here. Here in the kitchen, all of these serving the countertops will be GFCI protected. Here's the dining area. Bedroom number 2, so within 6 feet of the door and around the room every 12 feet. Same with bedroom number 1, within 6 feet of the door, then around the room every 12 feet. Here's the living room. You have it sliding glass doors or a double door. Make sure you're within 6 feet of it, and then you have one every 12 feet. Here's the foyer. Okay, very good. So no point along the floor wall space shall be more than 24 inches from a receptacle outlet on countertops and work surfaces in kitchens and similar areas. Receptacle outlets in kitchens shall be GFCI protected. All 125 volt, 15 and 20 amp receptacles specified in 21052 shall be listed as tamper resistant per NEC section 406.12. Bathroom receptacles must be on a separate circuit protected by GFCI, and receptacle outlets shall be installed such that no point measured horizontally along the floor line is more than 6 feet from a receptacle outlet. This generally applies to habitable rooms. Figure 27 shows the lighting arrangement for the same residence. All luminaires are shown in their approximate physical locations as they would be installed. Always check the drawing to make sure the locations meet the NEC requirements. For example, if incandescent or light emitting diode luminaires are used in a closet, they must meet the requirements of NEC section 410.16b1. So if you have an incandescent luminaire in a closet, it has to be a minimum of 12 inches away from any shelves or storage areas. If it's fluorescent, it needs to be a minimum of 6 inches away. So here's their lighting. They have a light in the utility room with 2 3-way switches and a single pole switch controlling an outside light. Every exit leaving the house, if it's for pedestrian, if a person can walk through that door, you have to have a light on the outside of that door. controlled by a switch on the inside of the door. So here's sliding glass. They've got lights on both sides, controlled by a switch inside the door. Here's one in the closet. You're saying that's a dimmer switch? I don't know. Dimmer switch in the bathroom, dimmer switch in the closet. Here's one in the bathroom. There'd be an exhaust fan in it. Well, they've got a window. They don't need an exhaust fan if they have a window. But here's one in the bedroom. Okay. The notes are crucial elements of the drawing set. Receptacles, for example, are hard to position precisely based on the scale drawing alone, and yet the designer may call for an exact location. For example, the designer may want receptacles exactly 6 inches above the kitchen counter, backsplash, and centered above the dishwasher. This information may be entered in the notes, but not precisely on the drawings. .3.0, reading a commercial plan set. Commercial projects and plans are much larger and more complex than residential projects. As a result, a typical set of commercial plans contains many sections. The specific sections and order may vary slightly, but most follow the order shown in Figure 28. So you've got your civil, it's an aerial view of the building location. Architectural shows you a floor plan, a roof plan, elevation drawings, section drawings, detail drawings, and door and window schedules. Structural will show you general notes, foundation plans, materials used. Mechanical drawings will show you motors, piping systems, and HVAC. Plumbing drawings will show you plumbing layouts and fixtures. Sewage and electrical drawings will show you the electrical supply and distribution and the lighting plans. 3.3.1 Electrical Site Plans. The site plan, sometimes called the plot plan, is the beginning point of a new electrical construction work. Electrical site work is sometimes shown on the architect's plot plan. On-site work involves many crafts and utilities such as gas, telephone, electric, and television, water, sewage. Drawing sheets can be confusing. In that case, it's best to have a separate site plan for the electrical work. Figure 29 shows an electrical site plan from a small office warehouse building. The electrical drawings consist of 4 large drawing sheets and a set of written specifications. So here's our north arrow. This is the proposed location of the new property. I'd say this is a parking lot. Okay. When you look at a set of electrical drawings for the first time, always look at the area around the title block. This is where most revision blocks or revision notes are placed. If revisions have been made to the drawing, be sure to have a clear understanding of what has taken place before proceeding with the work. Each sheet shows blocks similar to the one in Figure 29. Also check the scale on each sheet. Every sheet will use the same scale unless otherwise noted. Refer again to the drawing in Figure 29 and note the north arrow in the upper left corner. A north arrow shows the direction of true north to help you orient the drawing to the site. Look directly down from the north arrow to the bottom of the page and find the drawing title Plot Utilities directly beneath the drawing title. You can see that the drawing scale is 1 inch equals 30 feet. This is an engineer's scaling in which 1 inch on the drawing represents 30 feet on the actual job site. This scale holds true for all drawings on the page. On the site plan, you can see an outline of the proposed building labeled Proposed Building, Finished Floor Elevation, 590.0 feet. This means that the finished floor level of the building is to be 590 feet above mean sea level. On this site, that will be about 2 feet above the finished grade around the building. This information helps the electrician locate conduit sleeves and stub-ups to the correct height before the finished concrete floor is poured. Let's see here. I don't have any highlights. I'm just going to keep going. Caution, it's important for electrical workers to know the main gas line's approximate location while installing the direct burial conductors for the exterior luminaires. 3.3.2 Power plans. When the physical location of all wiring and outlets are shown on one drawing, the drawing can become difficult to read. For this reason, most projects have a separate drawing showing outlets for lighting, power, signal, and communications, special electrical symbols, and related equipment. Riser diagrams and details may be shown on another drawing itself sheet. If there's space, they may be shown on the lighting or power floor plan sheets. All right, so here's electrical power plan. It's showing the, I'd say that either the transformer pad or a transformer vault. I don't see any information. Here's the symbols list for all of the electrical on that. Figure 31 shows an enlarged version of the key plan from figure 30. Key plan identifies the part of the project to which the current sheet applies. So it's applying only to this part of the building, which is here. There you go. Key plan, no scale, no electrical work in part A. The outline of part B is cross-hatched in the key plan, meaning the sheet applies to that building. Note that this key plan is not drawn to scale, only its approximate shape and orientation are shown. Although Part A is also shown on the key plan, a note below the key plan title indicates that no electrical work is required in Part A. Okay. On larger installations, the overall project may involve several buildings. Key plans are included on each drawing to help workers orient the drawings to the appropriate building. In some cases, separate drawing sheets may be used for each room or area of an industrial project. Again, it requires key plans on each drawing sheet to identify applicable drawings for each room. And here's a list of different symbols used on the drawing. 3.3.3 Power Plan Details. There we go. Figure 33 shows a slightly enlarged view of the electrical floor plan drawing. Because the project is large and complex, it's still difficult to see much detail. This type of drawing is meant to show the overall layout of the floor plan and how the symbols and notes are arranged. So here's a cut view. That's on a different page. This is showing some lighting, or these are motors, probably exhaust fans, if I had to guess about it. Exhaust fans, what does it say here? Oh, that's not, it's pointing here. It says space for telephone equipment. Okay. Yeah, some of these notes I can't make out. It says, don't just check the electrical plan. It's important to review all the drawings in the drawing set, not just the electrical plans. Several drawings in the set will have information relevant to the electrician. For example, you should review the following: site plans for utility lines, mechanical drawings for routing, clearance, and HVAC equipment, architectural drawings for the type of construction, finish drawings, room finish schedules for ceiling heights and floor and wall finish details, and plumbing drawings for pumps, water service, and sprinklers. Here's a highlight. It says, in general, this plan shows the service equipment in plan view, receptacles, underfloor duct systems, motor connections, motor controllers, electric heat, busways, and similar details. The electric panels and other service equipment are drawn close to scale. The locations of the electrical outlets and similar components are only approximated by the drawings because they have to be exaggerated in size to show up on the print. To illustrate, a common duplex receptacle is only about 3 inches wide. If such a receptacle were to be located on the floor plan of this building, Even a small dot on the drawing would be too large to draw the receptacle exactly to scale. Figure 34 shows two runs of busways, one running the length of the building on the south end, one running the length of the north wall. A symbol list shows this busway as General Electric type DK100. These busways are fed from the main distribution panel, circuits MDP1 and MDP2 through GE number DHIBBC41 tap boxes. NEC Article 100 defines a busway as a raceway consisting of a metal enclosure containing factory-mounted bare or insulated conductors, usually copper or aluminum bars, rods, or tubes. It's a busway. Always check the relationship of the busway as its hangers of the building to the building construction before you start the installation. This will help you solve problems in advance that are due to space conflicts, inadequate or inappropriate support structures, openings through the walls, etc. Okay, let's see. Other details include the general arrangement of the underfloor duct system, junction boxes and feeder conduit for the underfloor duct system, plan views of the service and telephone equipment, and duplex receptacle outlets. A note on the drawing requires all receptacles in the toilet to be provided with ground fault circuit interrupter protection. That makes sense. 3.3.4, identifying luminaires on a lighting floor plan. The next few figures show electrical drawings for a textbook publisher's office. Figure 34 is a partial view of the lighting floor plan drawn to a scale of 1/8 inch equals 1 foot. The symbol for the lighting in drawing are drawn to indicate the physical shape and approximate size of the fixture. Different engineering professionals may use different ways to identify fixtures, such as how it is seen in figure 34 or a code inside of a triangle or other shape. Table 3 is a partial luminaire symbol schedule for this plan set. Fixtures identified with an E at their end are for emergency lighting and not separately listed on the schedule. The schedule gives the details needed for the selecting and installing each fixture. So they're saying all the emergency fixtures will just have an E at the end of the name of them. A 2x4 recessed. This A4 is a 2x4 indirect recessed. A B1 is a 2x2 recessed. A B2 is 2x4 recessed. C1 is a 6-inch downlight with different wattage. The C2 is 32 watts as opposed to 36. C3 is 18 watts. So all of these different lights. (3.3.5) Correlating information between plans. Very often the electrician will have to work in spaces crowded with other mechanical or piping systems. It is particularly true near electrical and mechanical equipment rooms. It is important to show how to read drawings for other systems in the same building. Next 4 drawings are the different systems in a single area of the same publisher's building. Figure 35 is the power, figure 36 is the lighting, figure 37 is communications, figure 38 is the mechanical or HVAC. So we can see all of our electrical panels installed in the electric room. Here's the lighting. Here's a switch. These nodes are probably outputs to a controller. Here's that same area. Main electric room, room 148. They're showing the GFCI receptacles. They're showing the receptacles that are on the walls. We won't show them at the same time as the power, as the lighting plan. And then here's a mechanical drawing or a partial communication detail. So they're showing the communications, TV, phone. There's another TV outlet, specialty outlet. Very good. Then the partial mechanical, this is showing the air ducts, HVAC, where they're going in those rooms. Figures 35, 6, 7, and 8 are a small portion of the plan set for these offices. Each figure shows less than 10% of the content of its full sheet. The full set has 107 sheets, with the electrical portion taking up 17 sheets. Other sheets show details, elevations, and schedules necessary for completing the work properly. Checking and correlating the information on plans can take a lot of time. Do you see a need to coordinate the installation of the cable trace shown in figure 37 with the ductwork in the hallway in figure 38? Or on two drawings, you'll find the air handler marked WSH-P14 in the main electric room, but the lighting drawing shows a fixture of the same location without showing the air handler. This emphasizes the importance of examining the drawings thoroughly before completing the installation. 3.4.0 Schedules, Block Diagrams, and Schematic Diagrams. A schedule is a table that lists specific types of related information on a drawing. Electrical diagrams are drawings that show different electrical components and how they connect. They are rarely, if ever, drawn to scale. 3.4.1 Drawing Schedules. When properly organized throughout your thoroughly understood, schedules are powerful time-saving devices for those who prepare the drawings and workers on the job. For example, a luminaire lighting fixture schedule lists the luminaires and identifies each luminaire type on the drawing by number. It shows the manufacturer and catalog number of each luminaire, along with the number, size, and type of lamps required. Panel board schedules usually identify the panel ID, the type of mounting, panel mains, phases, and the numbers of wires. A 4-wire panel, for example, is for a 3-phase panel with a solid neutral. For each branch circuit, the schedule lists the type of overcurrent protection, number of poles, trip rating, and catalog number, the wire size, and the load being fed. Panel board schedules also frequently gives the calculated load for each circuit and the total load on the panel board feeder. See figure 39 for a small panel board schedule. So here's the panel board schedule. It would tell us what the panel's name is. It might be LP1 or HP1. Oh, they're saying the panel number is MDP, main distribution panel. Cabinet type is surface, 600 amps, 120 volt, 208 volt, 3-phase, 4-wire. And then it shows all of the different circuit breakers. They're all 3-pole circuit breakers, 225 amp, 100 amp, 100 amp, 60 amp, 70 amp, 70 amp, 600 amp, and the frame size of each. Items fed or remarks, it's panel A. So the first circuit breaker, 3-phase, 225 amp circuit breaker, feeds panel A. The second one, a 3-phase, 100 amp, feeds panel B. Third circuit breaker, 100 amp 3-phase, feeds a power busway, and the 60 amp feeds a lighting busway. The 70 amp feeds a rooftop unit number 1, and 70A, this one is a spare. They'll use it for future. And then they have a 600 amp 42,000 main circuit breaker. That's the main circuit breaker for this panel, MDP. Other schedules often found on electrical working drawings include the following: connected load, electric heat, kitchen equipment. Depending on the type of project, these schedules may include lists of equipment such as motors, motor controllers, and similar items. The information in these schedules provides details for wiring identified pieces of equipment shown on the drawing. The electrical drawings for the publishing company's office building include the following: a luminaire schedule, a transformer schedule, a feeder schedule, mechanical equipment connection schedule, and 15 panel board schedules. Block diagrams, 3.4.2. A single line block diagram or a one line diagram is typically used to show the arrangement of electrical service equipment. A power riser diagram is a common example. Here's a highlight. It says power riser diagrams show all pieces of electrical equipment as well as the connecting lines used to indicate service entrance conductors and feeders. It shows you the logical progression of what feeds what. It doesn't show you in real time how far away these cabinets are from each other. They might be real close or they might be far away. Here's the current transformer cabinet. So their meter runs on a current transformer. They have 8 350 kc mil and 2 3.5 inch conduits coming into this current transformer cabinet. That's feeding the main distribution panel. And from there, we go up from the main distribution panel to these busways. Here are 1, 2, 3, 4, 5, 6, 7 typical busways. One of these goes to unit number 1 on the rooftop, 60 amp 3-pole non-fused stainless steel disconnect. This feeds panel A. That was that I think 250 amp that we talked about. And panel A feeds rooftop unit number 2 with 3 number 10s and a 3/4 inch conduit. It's a 30 amp 3-pole non-fused switch disconnect. Snap switch, excuse me. Non-fused snap switch weatherproof disconnect. So they tell us these 2 risers are 4 number 2 gauge and 2 inch conduit. And these are 3 number 6s and a 1 inch conduit. So they're typical. Here's a 30 amp 3-pole fused snap switch, 20 amp plug fuse for emergency lights and fire alarm. Here's the fire alarm control counter dedicated circuit marked in accordance with NEC Article 760. Okay. So that's a one line or a power riser diagram showing the whole building. Here, the block diagram, oh, don't do that. The block diagram is a single line diagram used to show electrical equipment and related connections. It's the same as a one line. The one line diagram is a drawing that shows by means of lines and symbols the path of an electrical circuit or system of circuits along with the various circuit components, also called a single line diagram. All right. This one shows the service mast. Here's the service head, or the weather head and the mast. This is 3/3/0 copper THW conductors and 2-inch rigid conduit, service head. Here's the meter base. There's 3/3/0 copper THW conductors and 2-inch rigid going to the panel. And then from the panel, they have a number 4 gauge bare copper wire that goes to the cold water pipe, and conductor need not be larger than a number 6 gauge copper or a 4 gauge aluminum wire to a driven ground rod. All right, that's the one line diagrams. Schematic diagrams. Complete schematic wiring diagrams are normally used only in complicated electrical systems such as control circuits. For complex pieces of equipment and control systems, 2 different types of schematic diagrams may be used. One type is similar in form to a one-line block diagram. In this diagram, the components are within blocks, and the wiring is abbreviated to a single line because these blocks are a group of blocks. When drawing like this, The individual wires are uniquely identified when they branch from the single line assembly onto the components within their blocks. Let's take a look at that. Here you go. Here's a block diagram. Motor starter wiring diagram. So they're showing the incoming power going to a three-phase disconnect or a three-pole disconnect. That's going to the motor starter. There's a contactor with auxiliary contacts. Here's the coil. And lines 1 and 2 come off and feed the starting circuit. So you go through the first stop and the second stop, and then you go through the 2 starts, and then they'll go to the line side of the contactor, and this constant hot is going to go to the other side of the holding contact, so that when this contactor energizes, this holding contact will close, and that constant hot will feed that contactor hot. Goes through the overload relay, and then comes back to line 2. Here there's a highlight. This says the motor power flow starts at the disconnect or terminals typically marked L1, L2, and L3, and then goes through the contactor and the thermal overload sensor using terminals typically marked T1, T2, and T3 on the motor. The control wiring takes power from L1 ahead of the contactor through both normally closed stop push buttons to both normally open start push buttons. Pressing either start button puts control power through the contactor coil and normally closed overload contactor to L2. When the contactor closes its auxiliary contact, wired in parallel with the start push button, seals in the operation of the contactor. The power is applied to the motor until either stop push button is released, is pressed, or an overload occurs. All right. Note, schematic wiring diagrams have only been briefly introduced in this module, but there are many other details that you'll need to know to perform your work proficiently. Later modules cover wiring diagrams in more detail. All right. 3.4.4 Drawing Details. A set of electrical drawings will sometimes require large-scale drawings of certain areas that are not clearly shown on the small-scale drawings. For example, the site plan may show the wiring electrician must install before the concrete contractors pour the concrete base for the exterior pole-mounted luminaires. A detailed drawing is a drawing of a separate item or portion of an electrical system. It provides a complete and exact description of an item or system's use and all the details the electrician needs to know for its installation. Detailed drawings are indicated using sectional cuts with alphanumeric designations to identify their locations. Figure 42 shows a detailed drawing of a door's security wiring for an office building. So here's the door itself. Here's the electric strike. And it shows how that electric strike is being controlled. There's a junction box. They're showing you all of the different things that go through this. Passive infrared, it shows that somebody's there. It'll allow you to leave the building, but you have to have the button depressed in order for that magnetic contactor to open, to allow the door to open, the door strike. All right. Here's 3.0.0 section review. So go over these. If there's anything that you have trouble with, write it in the comments and we'll all look for the answer together. All right. I'll see you on the next section, 4.0.0.